Hello everyone, today we're going to solve this logarithm question that seems pretty difficult from the start, but it's actually not as difficult as it might seem. So let m and n be integers both greater than 1. The product of the solutions for x of this equation, 8 times log base n of x times times the logarithm base m of x, minus 7 times the logarithm of n of x minus 6 times the logarithm of m of x minus 2013 equals 0. Now, the product of the solutions for x of this equation is the smallest possible integer. So what is n plus n if the product of the solutions for x is the smallest possible integer? So, the first thing that I can think of doing here is to change this equation so that we have at least a log base 10 of x, because we want to solve for the product of the solutions for x, but for now let's just try to get into the logarithm form without any base m or n. So let's see, how do we do that? Well, we can do the change of base formula over here and make it a base 10. So instead of this right here, we have 8 times 8 times log base 10 of x times log base 10 of x. So log base 10 of x gets squared, and then you divide it by log base 10 of n and log base 10 of m. Log base 10 m, log base 10 n. Now let's do it over here. So if we do it over here, we get base 10 of x divided by base 10 of n. Over here, we get base 10 of x over base 10 of m. So there's both after using the change of base formula, both of these will have a log base 10 of x variable. So we can factor that out actually. So we'll have a minus, in parentheses, 7 divided by log base n plus 6 divided by log base m times log of x minus 2013 equals 0. So if you take this and go back, then you will get this equation, and you can check that if you'd like. So now what? Well, we have log base 10 of x. Let me put a 10 right there. So we have log base 10 of x, but we're trying to find x. We want the product of the solutions for x, not log base 10 of x. However, this is the main thing in the problem. The sum of the solutions for log base 10 of x will be the product of the solutions for x. This is why. Let's say the sum of the solutions for log base 10 of x is log of a plus log of b plus log of c. Right here. This is the sum of the solutions for log of x. Well, logarithm rule, you can multiply these together to get log ABC, right? And then, of course, this is equal to log of x. So, it's equal to the log of x. You could say the sum of the solutions of log of x is equal to that. Well, if you get rid of the logs on both sides, you get x equals ABC. The product of the solutions for x. From the sum of the solutions for log of x, you get the product of the solutions for x. And that's basically what it is in this case. So, let's see. So we have this. Let's find the sum of log base 10 of x of here. It will be, by Vieta's formulas, negative b over a. So it will be this right here divided by this right here. So, it would be, 7 over log n plus 6 over log m divided by this thing, this coefficient for log base 10x squared, 8 divided by log m log n. So that's the sum of the solutions. So, let's see, what can we do next? You can simplify this. You can put this denominator up, switch it around, normal thing. And then after that, you'd get this these two logarithms will cancel in the denominator, and you'd get 7 times log of m plus 6 times log of n. And the 8 is still here. So we have this 8. So this is the sum of the solutions for log of x. Can we simplify any further? Yes, we can. We can bring the 7 up as an exponent and the 6 up as an exponent because of the logarithm exponent rule. So we have log base m to the power of 7 plus log base n to the power of 6. And then we can take the 1/8 too. We can also take the 1/8 and distribute it as a exponent. So after we have m to the power of 7 plus, log base m to the power of 7 plus log base 10 n to the power of 6, and we divide it by 8. Multiply these, again, logarithm rule. You can multiply these together to get log of m7n to the 6th, and of course you have the coefficient here, and then bring this 1/8 over as an exponent. Now what I mean by that is now it's log m7 and 6, but also all of this to the power of 1/8. So we're getting there. I mean, this is the sum of the solutions for the logarithm, but it's for the logarithm, right? Log of x. But we want to find the product of the solutions for x. But remember how we established it over here. The product of the solutions is just the sum of the logarithm of the solutions. So to get the product of the solutions, all we have to do is cancel out these logs. So now you have the product is equal to m to the 7th times n to the 6th to the 1/8 power. And now, let's see, what was it even asking for? It asked for the so it asked for m plus n, but we forgot, we didn't forget, but we need to remember this. The product of the solutions for x is the smallest possible integer. So now it's just a basic, Diophantine, I mean, it's kind of a Diophantine equation. We pretty much have to find the smallest integer value for this if m and n are both integers and greater than 1. So now you just have to test out a couple features. We know that, I mean, obviously we can't use 1, it has to be greater than 1, so we just use 2. So we have 2 to the power, 2 to the power of 7 divided by 8, 2 to the power of something, x, times 7 over 8, and then 2 to the power of some other thing times 6 divided by 8. And we have to find what these x and y is. Let's see. Now, honestly, there really is no rhyme or reason to this. You just have to test out a couple numbers for x and y, maybe 1, 2, 3, until you find some combination that actually works. And in the end, you will get that if x was 2, then that would make this 2 to the power of 14 over 8. And if y was 3, then that would make this 2 to the power of 18 over 8. And that would give you 2 to the power of 14 over 8 plus 18 over 8, so that's 32 over 8. And that's 2 to the power of 4. That is 16. So, what did the question ask for? M plus n? Well, m in this case was 2 to the power of 2, and n was 2 to the power of 3. So, we get 4 plus 8, and that gives us 12. So, I mean, for a final 20 AMC problem, this isn't too bad. Really, the most difficult part was realizing that the sum of the logarithms is equal to the product of just the x with no logarithm. But other than that, that's pretty much it. If you have any questions, please feel free to ask me, and I will do my best to answer them and make it a good one.